Welcome to the spoken tutorial on block component modeling. In this tutorial, we are going to learn how to define a block, how to connect blocks, how to use blocks from Modelica library. To record this tutorial, I am using Open Modelica version 1.9.2. You may use any of the following operating systems. To understand and practice this tutorial, you need knowledge of component-oriented modeling in Modelica. Prerequisite tutorials are mentioned on our website. Please go through them. Let us now learn more about blocks. Block is a specialized class in Modelica. It is useful in control applications. For example, Modelica library has blocks for PI and PID controllers, which are frequently seen in chemical engineering control applications. Variables of a block class must have fixed causality, either input or output. Blocks can be connected using connect statements. We have learnt about connect statements in previous tutorials. Connectors act as interface between blocks. They are used to model input and output signals. For example, this is declaration for a block connector that models real input signals. Let us now try to understand block component modeling through an example. Let us write a class that uses blocks to perform the following operations. Take two time varying signals as input and output their sum. Take a time varying signal as input and amplify it by a constant. Let us define this problem statement in detail using schematics. This figure shows a schematic for block that takes two signals as input and returns their sum. To make things simpler, let us choose signal 1 to be t, which represents time. Let signal 2 be 2 times t squared. This is schematic for amplification of a signal. It is similar to the previous case with two inputs and one output. Let us choose one input to be our signal. Let the other input, that is signal 2, be a constant k by which to amplify the signal. The product of these two inputs is the output required. We have chosen the signal 2, that is k, to be 5 units. Notice that both the sum of signals and amplification require a block with two inputs and one output. Modelica library already has a block named MISO that stands for multiple input, single output. It is available in modelica.interfaces.block package. The input to this block, U, is a vector since it can accept multiple signals as input. Y is the output, which is a scalar. Let us now discuss how to solve our problem using OMEdit. Extend MISO block to create a block named sum. We have learnt about extending a class in previous tutorials. Extend MISO to create a block named product. Create a class named main. Create instances of sum and product blocks in the main class. Lastly, program the necessary equations related to input and output variables. Note that sum corresponds to the sum of signals, whereas product corresponds to the amplification of signal. I have already created the necessary blocks and packaged them into a file named arithmetic operations using blocks. You may locate this file on our website and download it. Let me now switch to OMEdit. I shall first demonstrate the package arithmetic operations using blocks and then demonstrate the syntax of MISO block. I have already opened the package Arithmetic Operations Using Blocks in OMEdit. Let me expand it in the libraries browser. Note that the package has blocks named sum, product, and a main class. Double click on all three of them. Let me also open Meso block from Modelica library. Expand Modelica library. Go to blocks, interfaces, scroll down a bit. Double click on Meso. Interfaces package also has several other blocks which are similar to Meso in functionality. Now let me shift OMEdit window to the left for better visibility. Let us first look into sum block. Switch to text view if it opens in diagram view. This is the syntax for declaring a block. This statement is used to inherit Meso block from its location in Modelica library. We have learnt about class inheritance or class extension in previous tutorials. Let me now take a step back for a moment and demonstrate Meso block. Go to Meso tab, switch to text view. Meso is a partial block, which means that it can only be inherited but not instantiated. It inherits block class. You may locate this in Modelica library using the path shown. This class is used here only for the sake of its diagram view and hence need not be discussed. NIN represents the number of inputs. This parameter may be changed when the block is inherited. Real input is a connector which evidently represents a real input signal. In this case, the input is a vector u, as we already discussed. Similarly, real output is a connector which represents a real output signal. Here, y is the real valued output signal. Real input and real output are present in the same package of Modelica library as Meso. Please look into them. Now let me show you how the diagram view of Meso block looks like. Let us now go back to sum block and continue from where we left off. Variables y and u are a part of this block since it inherits Meso. As we have learnt in previous tutorials, sum is an array function. It takes an array as input and returns the sum of its elements. Let me switch to product block. Switch to text view. This block inherits Meso as well. As we have seen in previous tutorials, product is an array function that takes an array as input. It returns the product of its elements. Let me now switch to main class. Switch to text view. These statements indicate the instantiation of sum and product blocks. These instances can also be created using the drag and drop functionality of OMEdit. We discussed this feature in previous tutorials. NIN is a parameter for dimension of input vector u in Meso. We assign a value of 2 to this parameter. This equation indicates the values of signal 1 and signal 2 for sum of signals, which we discussed in slides. Similarly, this indicates the values of signal 1 and signal 2 for amplification of signal, as we already discussed. Let me now simulate this class. Click on Simulate button. Close the pop-up window. Expand My Sum in Libraries browser. Select Y. Note that this generates a plot that is in accordance with the values of signals provided. This brings us to the end of this tutorial. As an assignment, look into the codes for real input, real output, SI, SO and MIMO blocks. You can find them in modelica.blocks.interfaces package. Real input and real output are connectors which are used quite frequently. Hence, it is necessary to understand them. Watch the video available at the following link. It summarizes the spoken tutorial project. We conduct workshops using spoken tutorials, give certificates. Please contact us. If you have questions in the spoken tutorial, please visit the web page mentioned. We coordinate coding of solved examples from popular books. We give honorarium to contributors. Please visit our website. We help migrate labs from commercial simulators to Open Modelica. Spoken Tutorial project is supported by NMEICT, MHRD, Government of India. We thank the development team of Open Modelica for their support. I would like to thank you for joining me in this tutorial. Goodbye.